Thank you very much. Thank you for having me here. It's a real pleasure to be here with you. So we're going to talk about serving machine learning models easily with FastAPI. First, who am I? I'm Sebastian Ramirez. I work at Explosion in Berlin, Germany. Explosion are the creators of Spacey, you might have heard of. It's a natural language package, open source. Prodigy is a tool to annotate data with active learning. Think is a new deep learning framework using functional ideas and type hints, like to power everything underneath. I created FastAPI and I created Typer. That's why I'm here. I'm working in Germany, but I'm actually from Colombia. That's why my accent. Okay, so quick stuff about FastAPI. It has 8,000. It actually has 9,000 something GitHub stars. It has been growing like quite a lot recently. Like people seem to have liked it. It's used by Microsoft, Uber, and a bunch of other people and institutions. The performance you get when using FastAPI is in the top rank available for web frameworks in Python. We're not going to talk about anything around anything of those things. Just like, why will it be useful for you, machine learning people, to use FastAPI? So I'm gonna assume that you know machine learning. You know how to build your models. You have your models somewhere. I won't tell you anything about machine learning. You have the basics of web API development. You know, like what is HTTP, what is JSON, these basic things. So let's say that you have a model. Let's say that you have a Spacey model, and you're doing natural language processing. So you are reading some text and you're extracting the entities in the text. So this is just like very simple. Like you could be reading images, you could be reading, I don't know, some binary files, but you're taking some input data, you're generating some predictions with your model. And then you need to make it a web API. You need to provide it with a server for your colleagues to integrate it with other applications in your, I don't know, in your company, or you need to deploy your model to production directly, and you're in charge of that. So you might know a lot of like, I don't know, Jupyter Pandas and like very hardcore stuff and the internals of TensorFlow and how to connect it with PyTorch. But now you need to deploy that as a web API to production. So let's see how the basics of FastAPI work before putting machine learning in it. So this is a basic FastAPI application. This thing over here, this will be a get operation, so an HTTP get, and then you declare what is the like the path that will handle this. If you have used other frameworks like Flask or Hog or some others, then this will be quite familiar. Then you just return a simple dictionary, and it will be converted to the JSON response for you. You don't have to return a response class or something like that. It's done automatically for you. Then you can also declare path parameters. This item ID will come here, item ID, and we use Python annotations everywhere. And they Python annotations, for example, this int here declares that this item ID is an integer, and then inside of your code you will get type checks. So if you do an incorrect operation between an integer and a string, then you will see the errors, and then you get the autocompletion and all this stuff. But then FastAPI will use this declaration to know that this is a path parameter. And we declare this q here. Q is going to be a string, and by default it's none. So by default it's none means that it's optional. You don't have to pass anything. Then FastAPI will know that it's optional. And because this is not part of the path, then FastAPI will know that this is a query parameter. And then it's going to parse that data from those places, like automatically for you. You just have to create the functions, decorate them, and add the type annotations that you will do with your normal code, and then FastAPI will convert that, like will use that to build your API. Then you can just return again a dictionary or any type of object. FastAPI will convert that to the JSON thing. So if we were to call this endpoint, it will look like this thing below. Let's wait for it to, okay, disappear. Yeah. So some domain slash items slash, this 5 will be the item ID that we declare, and then the query equals something, blah, blah, blah. That some query will be the string inside of Q. But if we don't pass the Q equals that string, then Q will be none. So you just declare it like that, and then by default, you get automatic documentation generated from your code. You get a user interface that you can access at wherever you deploy your application /docs, and then you get this documentation, and you can actually use it interactively and like use your API through the browser just from your code. You don't have to do anything else for this to work. Now let's say that you want to declare a body because you're receiving data. You're probably receiving some data to generate your predictions. So let's say that you're receiving something that will have a text that is going to be a string and a language that is going to be a string, just for the example. This is in a class data that inherits from this base model. This base model comes directly from Pydantic. And this is going to be converted, like FastAPI will use that to read data from the JSON payload, from the JSON body that someone is sending you to the request. And then we have app.post. So this is an HTTP post request that we're going to send. And we receive the data in this parameter data, and we declare the type of it, of being data, which is the class that we created. And then we can just use that internally and return it directly. Because we are declaring it as being a class of some type, that's the object that we, and FastAPI will use that and will give us the object of that type of class. So we are not actually receiving a dictionary, we are receiving an object that is an instance of that class that we created. So we can actually use data.text and it will work and it will get us the data that we want. We get like the documentation for this thing as we declare it. So we have in the example that we have a text that is a string and a language that is a string. This comes directly, let's go back from here, from this text and this lang. And we can try interactively in the same documentation, communicating with our application that is executing live. So we can execute some request, sending some text, sending some data that will go in the JSON payload, and then we receive the response here. So, so this, actually I think I should point with this one. So this response here, this message actually comes from this message that we are returning here, from this dictionary that we are sending like in the response. So then we can like interact and try our API while we are building it. Then let's say that we want to have a body, but we want to put the language in a query parameter. We can just separate that, add it to the parameters in the function, and then FastAPI will know to convert which comes from the body, which comes from the query, which comes from the path. And there are tools there are like components to extract information from headers, from cookies, and like everything. And then the documentation is generated automatically. We get that the lang is going to be a string, and it's going to come in the query parameter. And then we get that the body now doesn't have the lang, it just has the text. Also notice that we, in the code, now the lang doesn't have the equals none. So now this is a required parameter. And we can see it in the documentation here that this is now required. Now let's say that we have the machine learning model. So what you will do is just use your machine learning model inside of one of these functions. It's like pretty simple. You just read the data. This data comes from this parameter, and this parameter is of this class, that is this class we created here. So this will receive a JSON dictionary or a JSON object that will contain a text, and then this data.text will have that string that we are passing to our machine learning model. Then this is just the standard machine learning part. We are just iterating in each one of the entities recognized by your model, and then we just return the data. Again, just a dictionary. We don't have to create any instance of a response or something like that. And then if we try to execute it, we get the data as we defined it. But we don't have to constrain ourselves to having just a single JSON dictionary, a single JSON object with keys and values. We can have a list of these objects. And to use that, we just use standard Python type annotations. This list comes directly from typing. So this is a standard library. This is not some strange class. This is the standard way to declare a list of stuff in modern Python. So you just declare this data should be a list of this class, and then you will receive, in data, you will receive a list. This data will now be a list. We can iterate for each one of the items, and now each one of these items is going to be an instance of this class. So each one of the items will contain the attributes and the fields that we declared, the item.text that comes from here. And then we can just like return the rest of the response. And we can like structure this way, even like deeply nested data structures, however you want, and it's all just documented. You can see that now the default example shows that this is actually an array of JSON objects, so the equivalent of a list of dictionaries that have this content that should be received in the endpoint. Now, let's say that we send invalid data. So by default, by using Python type hints, FastAPI is using that to document the API, so you get automatic documentation of your API. Having automatic documentation is great to collaborate with others, so that other team members or front-end team or other services can like interact with your API and know what they should give you and what they will receive. But it's also great for yourself to be able to test your own API and know that it's working as it should work. So you don't have to be guessing or using other programs and other ways to send data to be able to know that it's actually working as you intended it to work. But now let's say that we send invalid data. So this one is, again, the list of dictionaries or the array of objects. We're sending the first is text. This has some string. Yeah, that's correct. That's what we defined. Then we send another text. This is correct. But then we send another one that is this object that doesn't have a text key. This one has this content key that we didn't declare. And we declared that the text should be there, but we didn't declare this content. And then we can also say like, yeah, we have this one has the key text, but the data is not what we say that we will receive. This is not a string. This is another dictionary or another JSON object. If we send that, we will receive automatically an error telling us exactly where the validation what the validation was broken, like where was broken, where our data was broken. So you want first your server won't explode, your model won't have to try to predict something from a dictionary when you were expecting to predict something from a string, because that part of the code will never be executed. The part of your code will never be executed before having valid data. So FastAPI using Pydantic will make sure that you have valid data before your code even has to deal with that. And we also get like exactly where are the errors. So we see that the field is required, this field text is required in the first incorrect example, which was the index 2 in the list that we sent. And we see that the text should be a string. The string type was the type that was expected. And what we sent was actually a JSON object, which gets converted to a dictionary. So we get all this sort of for free just by declaring our data types in FastAPI. Now, here are some of the other benefits that we get just because we are using standard Python type annotations. We declare that this is a class that has the text attribute. And we declare that the input data is a list of objects of this type, of the data class that we created. And then we iterate for each one of these items in data, this is a list. For each one of these items, we get automatic auto-completion for each one of the items with the attributes that we declared. So we know that it has a text attribute, and we know that this is of type string. So you could go item.text.uppercase or whatever, and you will get completion for all those things. Having this completion inside of deeply nested data structures is not common, and it's not like easy to get in with other tools and other frameworks. And this is like a very nice benefit that is just like for your to simplify the use of the language. Otherwise, you will probably have if this item was a dictionary, then you will have to type the string text as a key inside of brackets, and then you will have to remember that it has to be text and maybe you try to say like, oh, I want to get the message, and the key was not message, the key was text, and then like having to have all those, having to remember exactly what you declared is many times like difficult. So having this completion is quite useful if you use completion. There's some people that have great memory and just can do it like by memory. I can't, but then that's one nice benefit. Another benefit of using standard Python type hints is, let's say that we declare that the data should receive an ID. This is an integer. And again, this is a standard Python notation. So this type of class, this is actually the same style that you will use with data classes. Data classes come with Python 3.7. They're part of the library. And this is the same way, this is the way that we are declaring these attributes is the same way used in data classes. So you're not importing something that is an integer class. No, this is just the standard Python int. And this is the standard Python str, standard Python string. But then we get one of these items that are in the list, and we try to sum the text plus the item ID. We get this error here in your editor, and this is not really because of FastAPI, this is because of Python. This is because you are using standard Python type hints. So then you're getting this error telling you that string and int cannot be used with this operator. You cannot sum a string with an int. You have to convert the int to a string before being able to sum it. So you get these errors automatically in your editor before having to run your code, before even realizing that there could be a bug in production. Like you have these types of bugs, like you can realize you could have these types of bugs early while developing. And again, like it has like all the tools that you will expect from a normal framework. You can read files directly that will be sent as form data. In this case, we are declaring what is the type of this parameter as upload file. These upload files come from FastAPI. Then we declare this equals. This equals, we use it before to say equals none, to say that something was optional. Now we are using it for something else. We're declaring extra metadata. By using this file, we're telling FastAPI that it should read this file thing from form data as a file attachment. And then because we replaced the none here, then we could add the none here to say, okay, this is optional. But in this case, this is not optional. So we use these 3 points to say this is required. These 3 points, if you have not seen them before, this is called ellipsis. This is a symbol in Python. So this is valid Python. And you can use this ellipsis in your own code. This is used by FastAPI to detect that this is a required parameter that should come from form data as a file attachment. Then you can just read the file and do the same machine learning again as you would. So this is like the standard types of things. You could also like use templates if you want to. You could use like all these same tools that you will use in other frameworks. And again, like the documentation is updated and you get like this nice widget that you can trigger to upload an actual file and send it to your API and see how it behaves. WebSockets. WebSockets are like very common now, and people is like, yay, WebSockets. So WebSockets allow you to do real-time communication. WebSockets was quite difficult in previous versions of Python with the previous standards and frameworks. But recently, with the work of Andrew Godwin, that you probably heard the keynote this morning, he wrote the specification, the ASCII specification, that allows us to do asynchronous web frameworks. FastAPI uses that same specification, the same specification that was born in Django channels, and that is what powers us, what allows us to do WebSockets just using async code. FastAPI is an asynchronous framework, but you don't have to do any asynchronous code. You don't have to even understand it that well. All the functions we have used up to now, if we go back, all these functions are standard def functions. They are not async def. So you can just use normal def functions. FastAPI will run that code inside of a thread pool so that you are not blocking the main event loop in case you know what that stuff means. But otherwise, you can just like run your normal code as you would using normal functions, and then it will do the right thing for it to be able to work. But then let's say that you want to have WebSockets. The common example is chats. Chats, I would say, is not necessarily the best example because you don't really need to see each character that the other person is typing exactly at the time that that person is typing. You only need to see the message after the person hits enter. But still, you will get improved performance for chats if you want it. But let's say that you are doing machine learning over video and you want to read each frame, process the frame with machine learning, and send the frame back and play the frame with the machine learning stuff that you're doing on top right in the browser. Doing that through HTTP and sending one request per frame will be impossible. Then WebSockets will be a good fit for that use case. You could use it, WebSockets, if you need to do interactive animation. So let's say that I'm moving the pointer here, and I want some other users in their browsers to be able to see the same pointer exactly in the same location, exactly at the same time. That needs the data of the location of the pointer to be sent in real time or almost real time. So that will be a good example of something that will benefit from WebSockets. The same with synchronized text typing. So if you are live coding, you want to see the code that other person is writing. For example, recently the creator of PipX created an application with FastAPI to allow you to share your terminal session via a web browser. So you can run a program in your terminal session, then you just type stuff in your terminal session, and someone could be able to see as you type each one of the characters and each one of the prompts and each one of the text that you receive in your terminal prompt from a browser. And like multiple users could be using that. To be able to use that, then we need to use these async functions to be able to use async and await. But then it's quite simple. You receive a WebSocket. You can read data from the WebSocket. Let's say that we do the machine learning stuff, and then we send data to the WebSocket. So it's pretty simple, relatively familiar, and you can do WebSockets if you want. We can also do basic authentication. So let's say that you want to deploy your machine learning model. You have to show it to some colleagues. You have to upload it, put it in some server, and you need it to be like open, but you don't want everyone to go and use your model, but you don't want to spend a lot of time learning React to build a user interface to add authentication and stuff. So you could use just like this. This is HTTP basic authentication, which is triggered by the browser and handled by the browser directly. The way to do it, and it's actually integrated into the documentation, so you get the authorize button and all these things. The way to write that code, like writing authentication and authorization and security code, it's always long. It always takes a lot of effort and code, but still with FastAPI, you have the tools to use the things that you need. So we just import some tools, then we declare that these credentials come from this security thing. The security is a security scheme. And we are also using the dependency management system. You might not need dependencies that much if you're just deploying a simple model, but with dependencies, you will be able to get the current user in each one of your endpoints without having to read and like execute a lot of code in each one of the endpoints. Like you will be able to like reduce a lot code duplication by using these things. Then let's say that we check that we have the username and the password that are correct. And if we don't have a correct password, then we can just raise an HTTP exception. So this will be an HTTP error that tells the client, this data is invalid. I need you to send me the correct credentials. And then we just return this username. Now notice that this doesn't have any decorator here. This is not app.get, app.post, anything. This is just a function that has the same style of things declared here. And then we can use this whole function that we have to write only once in other path operation, in other like endpoints or path operations or however you call it, by using a dependency, which is part of FastAPI. We import these depends from FastAPI, and we pass the function that we created. Where whatever code is in this dependency will be run by FastAPI before running your code here. So you can add all the authentication, authorization, security, all the stuff just to these functions, and then it will be run for you. So you know that if this code is running, it's because the user is authenticated, is logged in, like all the security checks have passed, and then you put those security checks just in a single function. This function can return anything, so you're not constrained by having a specific class or specific data shape, so you don't have to have like a a class that has a username and a password, or something that has a token. You can return whatever you want from here. It could be a database model. It could be anything. That's the thing that you return from this function that is the dependency function that we created before. So if we scroll up, that will be this. And then if we scroll down, we are using that here. And this username could be like anything that we return. Then we just run the same machine learning standard code, and we just return this stuff here. We can also use OAuth2 with FastAPI. So OAuth2 is a set of specifications to do authentication and authorization with web applications and stuff. This is what Facebook, Twitter, Google, and all these guys use. Whenever you go to an application that says login with Facebook or with Google or with blah, 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 they are all using OAuth2 underneath. And when you give some permissions, that is all part of OAuth2. With FastAPI, you can easily create something that does that type of work of providing authentication and users and some specific permissions that your users could give a third party or stuff like that. Like you can make pretty complex stuff and stuff that could be difficult to even explain, but you can do all that easily with the tools provided. And this is the authentication integrated into the documentation. So you get also this for free for your documentation API, so that when someone is trying out your API, they will also they will get an unauthenticated error, or they will get like invalid data. They will do like the application will be running directly with that. The way to use that is also using something directly from FastAPI. Then we create this security scheme, and again we use one of these dependencies, which is just a function that declares stuff right as we declare it in path operations. We could use request stuff from bodies, from cookies, from headers, or anything here. This works exactly the same as a path operation. It's just that it's a function that is used as a dependency in other functions. So this is a dependency that uses this as a sub-dependency, and we could have like deeply nested dependencies or trees or whatever. And then we can just use that. We are using that dependency inside of here, and then we get a username. Let's say that this dependency receives a token, and then we can use that token to authenticate this user and then do the machine learning stuff. Therefore, the user, to get the token, he could send form data and send the username and the password, and with this, we generate the access token. So the user communicates with the API, sending the username and password. Then the API says, yes, this username and password is correct, and then it sends the user a token that the user then can use that token to communicate to the rest of the API. This is how this example works. You could use all this without being yourself the provider of the authentication. So you could use FastAPI and having a third party provide the authentication or something like that, and it will still work, and you can have like all these tools integrated. About performance, FastAPI, so the green ones are Go, blue ones are Python. You get like in the top rank of performance. Which one of these is exactly faster is not that relevant. This is quite some random noise. For example, FastAPI here is on top of Ubicorn, and Ubicorn is the server that is running FastAPI, so it's impossible for FastAPI to be actually faster than Ubicorn. But like this, you can see that they are in the same ballpark in the top performance for Python applications. You can see here there's like Flask, API hour, and then below is Django and like other stuff. Like you can see a bunch of other things there. But you are getting performance that is on top of some Go frameworks. And that's quite cool because like Go is a compiled language. Python is an interpreted language. And you are getting, like this is not apples to apples, and you're still getting quite good performance. And you're not having to develop a whole API in another language while you are doing machine learning in Python. So it will be like quite complicated to combine all these things together. You can just stay in the same language, use the same features, and get like quite a decent performance. Now, other tools, if you like these type hints and type annotations and these ideas, Typer is for building command line applications, not APIs, but command line applications. Is mostly the same as FastAPI. So these are the same ideas, but for command line applications. So you can just like write a function and they call it, and it will automatically generate the parameters and the arguments, and you will get completion in your code, and your users will get completion in their terminal. So like simplifies things. And if you're doing deep learning, you might want to check think, because it uses all these type annotations ideas and a functional style that might be useful if you're like exploring machine learning. If you're learning machine learning, this is probably not the tool to go. But if you are researching and doing advanced stuff and you want to mix PyTorch with TensorFlow and MXNet on the middle or something, you can do that using this in the middle to put everything together in the same model. That's what I have for you. I don't know if you have questions.